Hello class, this is Mrs. Ayodeji with today's video on 13.4 Infinite Geometric Series. As you're watching the video, please write down important vocabulary, formulas, equations, and notes. Feel free to pause, rewind, or repeat the video as often as you need to get a full and clear understanding of what occurred in the video. And at the conclusion of watching the video, submit that summary as well as a top question via the online WISC. All right, let's begin. So we've been talking about geometric series, and last video was about finite geometric series. And today we're going to talk about infinite geometric series, where the number of terms that you're summing is infinite amount of terms. Okay, so let's review one of the examples we used in the previous section about the 20 milligram drug that's being injected, and each day the patient's body metabolizes 50% of the present drug, so that after only one day, only half of the original amount remains. After 2 days, 1/4 of the original amount remains, and vice versa. And so we came up, it is a geometric series to represent the amount of drug in the body after n injections. And this is a geometric sequence that is used to generate the series. 20 times 1/2 to the power of n, okay, minus 1. And so after 10 injections, this is the amount that's in the blood, and we use the same finite sum formula that we used in the previous video to be able to calculate the amount in the blood after 10 injections, and after 15 injections, and after 20 injections, and after 25 injections. But what's interesting, even though the number of injections is increasing, the total amount of the drug in this system is at most 39.9999 milligrams, which seems to be some type of limiting power. And so the question is, can we show that the amount of the drug in the system will never go above that limiting value of around 40? And we can. If you recall, the finite sum can be calculated of this example using this experience. And the question is, what happens as n goes to infinity? Well, in this expression right here, the only part of the expression that's involving n is this part. And so 1/2 to the n power, as n goes to infinity, 1/2 goes to 0, because you have a small number, a number less than 1, being multiplied by itself, so it's getting even smaller and smaller and smaller. So at the end, the limit, as n goes to infinity, ends up being for the sum of the drug in the system going to 20 over 1/2, which is around 40 milligrams. Okay. So now let's take a look at the actual general formula. Again, we're considering a geometric series that looks like this, that can be represented like this. And if we look at the common ratio, if we're considering the common ratios where the absolute value is less than 1, then as r sub n goes to infinity, r sub n is also going to infinity, and that's only because the absolute value of r is less than 1. So therefore, using the same terminology, as n goes to infinity, this value right here goes to 0. And so we end up with this expression to represent the infinite sum, the sum of an infinite geometric series. And it's just involving the first value divided by 1 minus the common ratio. And this summarizes this. So in this case, S will be actually one number, and we say that the series converges, and it only converges, again, if the common ratio, absolute value of that common ratio, is less than 1. Now, some of you may be asking, what happens if the common ratio of that value is not less than 1? Well, that means then the series does not converge. Another word to express that is diverges. Okay, so let's take a look at an example. So in this example, we're asked to find the sum of 2 different geometric series. Okay, and so using what we know in this first series, this is the 17th sum. And so we use the expression that we use in the previous finite sum. The first value, initial value, times 1 minus the common ratio to the next power, 18th power, over 1 minus the common ratio. In this case, we get this expression. So now the question is, what about as it goes to infinity? Okay. Well, now because the absolute value of z is less than 1, and the reason why we know it is because they told us that, and this represents the common ratio, then instead of using this type formula, we're just going to use this formula where it's the initial value divided by 1 minus the common ratio, and this is our answer as well. Okay, I hope you enjoyed this. If you have any questions, please write down good thought, deep thinking, thought-provoking questions for the video. Thanks. Bye-bye.